Hello, wonderful students. We're going to go ahead and start a new unit. We're going to be in Earth's changing climate. But before you start this actual lesson, lesson 1.1 and 1.2, you need to go ahead and go into lesson 1.1 and complete the pre-test first. So make sure you go in and complete the pre-test first in lesson 1.1. We're going to go ahead and jump into 1.2. So today we're going to begin the new unit called Earth's changing climate. Like I said, you're going to need to complete the assessment. That'll help show you what you already know about the topics. So just do your best on it. All right, so we're going to jump into 1.2. In the Earth's Changing Climate unit, we're going to be thinking about what causes climate to change. So climate is basically general weather patterns over a long period of time. Now remember what I said. Climate change is general weather patterns that change over a long period of time. And that can include temperature, rain, sun, wind, like the changing of those things over a long period of time. Now, climate change is changes in the climate over a long period of time that can be caused by natural events or human activities. So it's things that either we cause or nature causes that changes our climate in an area over a long period of time. So if you need the glossary, you can use that at any time. You have it in your packet. You can also look it up on Amplify. You do have a glossary in the library. So we're going to watch a video about a real climate scientist to learn more about issues related to climate change. And we're going to hear what a real scientist says about the changing climate.
I'm Dr. Derek Lampkin. I'm an ice and climate researcher, and I study how large ice sheets respond to a warming climate. An ice sheet is a large block or mass of ice that covers an extensive area at the size of a continent. I spend my time thinking about the Greenland ice sheet. We're seeing 300 billion tons of ice being lost annually from the Greenland ice sheet. That's ice mass being dumped right into the ocean and making a direct contribution to sea level rise. So we're very much concerned about what the long-term health of Greenland is going to be. When you look at a large block of ice like Greenland, it might appear to you as if it's not moving at all. But it turns out that ice moves very slowly. The ice sheet moves from the center to the edges like a conveyor belt and breaks off into large blocks which go into the ocean and melt. What we're most concerned about in a warming climate is how fast that ice is moving to the edges and how much contribution the ice is making to sea level rise.
Here's the inside of one of the main tents at Swiss Camp.
I just got back from the Greenland ice sheet on a research expedition where we use GPS to monitor the movement of the ice. GPS operates just like it does in your car. It tells you your accurate location on the Earth's surface at any moment that you're moving. So we use the same kind of technology, but we connect it to poles that are frozen into a fixed position on the ice surface, and then as that ice moves, the pole moves, and we're able to monitor how fast that pole moves. Our data showed us something actually quite exciting. The ice was moving faster when there was more surface meltwater present in the summer. I became very much interested in understanding how much surface meltwater is being produced, how it flows across the ice sheet's surface, and how it makes its way into the ice sheet. Your job will be to help us map out these blue dots, which you can clearly see in the satellite image here. My students help me do this by utilizing images collected from satellites that are in orbit that take pictures of the Earth's surface. What'll look like maybe one channel is actually a network of interconnected. We're able to identify where the lakes are, where the channels are, and we can map out and understand how much they change and how much water they deliver into the ice sheet and its impact on the ice movement towards the ocean. Greenland has contributed over the last decade about 8 millimeters of sea level rise. Doesn't seem like that's a whole lot, but it matters under circumstances where you have hurricanes and storms slosh water onto the land and inundate coastal areas. The more the public understands how these ice masses influence their everyday lives or will influence their lives in the future, the more they'll have an understanding about how to impact policy so that we reduce the impact that humans have on the climate.
So you'll work as a student climatologist to help this World Climate Institute investigate climate change and educate the public about their discoveries. So we're going to read the message from Dr. Irene Lee, the head climatologist, on the next slide. And remember, the World Climate Institute is a research center that researches the causes of global change and tries to educate the public about it and mentor students. It mentors students that are climatologists as well and helps them learn more about what's going on. Okay. So Dr. Irene Lee, the head climatologist, is sending this to us. The World Climate Institute is pleased that you will be assisting us in reaching out to the public and explaining a complicated process, why the ice on Earth's surface is actually melting. To help you, you will need to learn how energy moves throughout the Earth systems and how this is related to temperature changes across the planet. This is a complex but important science, and explaining requires a complete understanding of the entire system so you can make sense of it for others. Only then will you be able to explain what is happening to our planet and why ice is melting so rapidly. So we're going to focus on why is the ice on Earth's surface melting in Chapter 1. And here's a claim related to ice melting on Earth. The claim is that the amount of ice on at the Earth's poles is decreasing significantly. Your first task as a student climatologist is to review the data that we have about this claim. It's important to be skeptical and look at the data carefully because some scientists agree with the claim that an increase in global average temperature caused ice to melt. At first, not all the evidence seemed to support the conclusion. So, why did some scientists initially agree that overall ice was decreasing? You and your partner will examine these graphs with data about the amount of sea ice that you have. And you have these in your packet, and you will get cards for these as well as you do your um, your lesson. So when you're reading the graphs, it's important to pay attention to the titles and the axis labels so you know what the graph is telling you about what it's talking about and what it's measuring and putting on the graph. So you are going to be completing this page in your packet and discussing these questions on the bottom. There is this is the end of partner work for this lesson. So this is another piece of climate change data on the global average temperature. It also shows a pair of concepts that are important to Earth science. In Earth science, it's important to have data from long enough time period to tell if there is an overall tendency that you're seeing or there's just variation. So do you see an overall trend? So for example, a consistent increase in data over a set of time, that's a trend that it's consistently increasing. Fluctuations is going to be variations of data going up and down, up and down. So we can see here it's going up and down. This graph shows temperature changes since the 1880s. The temperature goes up and down a lot, but the tendency overall is an increase. So it goes up and down a lot, but we see an overall trend of an increase in this data. If you only looked at the data from a shorter time frame example, here we have from, let's say, 1945 to 1950, you might say that it decreases, but that is just one of the parts of the fluctuation, the up and down changes. So we know that fluctuation is variations in a set of data. It's going up and down, it's changing, it's fluctuating. So if you follow the larger trend, you can see that the blue line on the graph shows you an overall increase in temperature. So if we look at everything, we see that it actually is going up. We see an overall trend that is increasing. So it's the tendency, or for example, the consistent increase in our graph in a set of data over time. So we know that graph A shows fluctuations in the sea ice, but if you look at a longer period of time on graph B, you will see that the trend is an overall decrease in sea ice. This is looking at specifically the sea ice. So remember that climate is the weather over a long period of time, and climate change refers to the ways that climates in regions on Earth change over long periods of time. So, to explain something's happening on Earth's climate, climatologists don't just look at the weather over a few days, months, or even years. They look at it for a much longer period of time to form their explanations. Trends in the data show what's happening over very long periods of time. We can see that the global average temperature is increasing and that the amount of sea ice in the Arctic is actually over time decreasing. So the data on the graphs leads us to this key concept. Although there are many fluctuations, there is a downward trend increasing temperature, or excuse me, there is a trend towards increasing temperatures and decreasing the ice on the Earth since about 1880. So an increase of temperature, decreasing the amount of ice. We have found that the evidence of the trend that has been happening since the 1880s is temperatures are increasing and ice is decreasing. So we're going to investigate what could be causing this. And we're going to pay particular attention to energy because energy is changing the temperature and making the melting ice that we have. We know that it is the ability to make things move or change. Temperature is also another we're going to focus on. Remember that energy is the ability to make things move or change, and we're investigating a decrease in ice and an increase in temperature. So temperature is just a measure of how hot or cold something is. All right, so that's the end of our lesson. And I'm going to hop back in here because you should be doing the digital parts. Check your Canvas page to make sure that you know what you need to complete. It may look a little different than this, so make sure you check your Canvas page. Have a wonderful day, you guys.